And it was like every
All
time I
right,
would shoot.
we're going to talk about the second segment of this this class. It's about Aerovanes. Aerovane is the first ever and the only airfoil-based vanes. And now let me just start by quoting Professor Selig. Everybody say, what's the deal? Everybody use feathers. Feathers have been used all the life of arrows. I say, just understand one thing. The bird do not fly with feathers. Bird fly with wings. The moment you understand feather is nothing more than a surface material of a wing. Why is Aerovane such a big deal? Because this is the first time ever. And just like another one I quote, how many birds you know that fly over 300 miles per hour? You won't even find a bird that flies over 110 miles per hour, even in extreme conditions. Now you've got Aero that's flying at 300 miles per hour. Now you really look at airfoils. And Aerovane is an airfoil. What does that mean? That means that the vane itself, based on the design, when the air passes through the vane, created lift. When you have 3 or 2 or 4 of the lift in circular, you end up with turns. Now let me just, before we start, I'll give you some numbers, so at least you know what the difference is. On a traditional bow, at 300 feet per second with feathers, the vanes have 0 effect for the first 10 feet because the vanes are collapsed. Until the bow is slow enough, the vane will slowly come out, feathers will slowly come out. Then you interact with it, it begins to turn. So if you shoot feathers on, say, hunting arrow at 300 feet per second, you've got about 3 to 4 turns in the first 20 yards. On the blazer, you've got 8 to 12. And you maintain that.
That is true.
The moment you go to Aerovane, on the Aerovane 2, at 60 yards, a blazer will turn 6 to 8 turns every 20 yards. Aerovane 2 is about 90 turns. Aerovane 3 at 350 feet per second, we know it's doing about 300 revolutions every 20 yards. So that's a huge difference in what's doing. Then people say, well, when you turn, don't you lose energy? This is where Aerovane comes in differently. You don't. Because the Aerovane is not just an airfoil. You've got a few very important features in it. Like this diagram will show you. Notice that this is actually an airfoil right here. This part right here. See that? And this is straight. So in other words, when air travel over this area, it's traveling a longer distance. When the air traveling on the lower side, it's slower distance. As to speed difference, when the air goes through, you create a lift this way. But that is where the basic things is. But this design, you notice every single part of Aerovane, you notice it's actually a triangle design, right, from this angle. But when you look, you return it 90 degrees. Look at this part. Guess what? It's also a triangle, but very slim triangle. In other words, this is actually a super slim pyramid design. So why this super slim pyramid? Why not behave like most other vanes? It's nothing more than a strict flat piece. Because every single strict flat piece has major problems. You're dealing with fluttering. Now you notice a lot of companies like Blazer, they put dots on the texture on the surface. It's to do boundary layer combating. You're combating boundary layers. So what I did say, well, if I'm going to do this, I'm also do this right. You notice that that is given zones in Aerovanes. The frontal area of the Aerovane is about 152,000 and the tail end is about 0.05 thousandths. In other words, as the air travels over the vane, the speed difference and how the turbulence on boundary layer is controlled. So in other words, I do not have back vacuum pressure on the backside, like a typical airfoil, because I want to combat it. Now by doing so, you notice very front part of this area, notice how round this area is? Which is this area right here. This is actually the same identical aspect ratio of an owl, of a North American barn owl. So that means when this vane going through air, there is technically no sound. And then with the boundary layer controlled, that means when you go through air, there's no vortexes. There's no vortex on the edge of the vane, which is your delta vortex, which is your #1 problem. Because the moment you create delta vortex, the vortex starts rolling over the vane, cause the vane to flutter. When you're fluttered, you got sound, you got uncontrollable directional force. That's the reason when you start shooting some of the other thing, when you put a heavy helical, you shoot it, go blah down the range. I always tell people, do you know deer do not jump strings? Deer jump veins and deer jump broadhead. You know why? The string only make one sound. Broadhead and vein get louder and louder towards the deer. The closer you get, the louder it gets. Now, how do you combat this? That's the answer. The another thing about veins, which most people never understood, the size of the arrow diameter have nothing to do with wind drift. When you start shooting 300 miles per hour, what's the crosswind? 30 miles per hour. Think through it. When you shoot an arrow through that air, what is the size actually affecting the arrow? Oh, look at the size the wind is blowing on this arrow. No, it's not. This is the size you're looking at. That arrow is going through that hole. So the only thing that matters, because we are not going to supersonic, we're in subsonic area right now. Unless you start shooting 780 feet per second, that's miles per hour faster, we are dealing with air. What happened with air as subsonics? The vein is going to interact with the air, which means that the air that the vein passes through is going to be pushed back. This is what we discovered. On a normal blazer 2.5 degree offset, when that arrow going through the air, you got a crosswind signature about 6 to 8 inches. That means when the arrow go through that air, 6 to 8 inches of column of air is being affected. But when the wind is blowing sideways, that's what causing the entire column of air to move. If you got a column that's 6 to 8 inches, compared to arrow that is 1 inch in diameter, what are you really pushing? 6 to 8 inches of column pushing that way. The arrow will drift. Now the answer is, how do you overcome it? Now in the case of the worst kind of vein is the vein that using a rudder, like the first generation quick spin, is approaching 18 inches in diameter. Now you know why if you shoot a low FOC, just like one time I was shooting a first generation quick spin with an 85 ring broadhead, with a 30 miles per hour wind, I shoot at the deer. The arrow slapped the deer sideways. The arrow actually do 90 degrees and slapped that deer in front of me. I was totally shocked. And that's where I think that something needs to be done. With the help of Professor Lele out of Stanford University and Professor Sid out of Central Illinois, which I hired as my consultant, I come up with this. This is the original structure of the Aerovane 2. Now, we actually go one step further. Inside this, we also understand that this is made of plastic, okay? This is a 92 durameter plastic, which is significantly stiffer than any plastic in the world for veins. What are the benefits? The benefit is that it's actually a true airfoil, have capability. And being a non-solid piece, non-rigid piece, non-very rigid piece, the vein is able to do aerodynamic elasticity memory. Now, that's a very long word. So in other words, as you shoot the arrow, the frontal part of the vein on the airfoil will skew towards the lift, and the tail end will go away from the lift. So by doing so, I'm teaching the piece of plastic based on necessity and speed to form the best, most efficient impeller form. So in other words, the plastic is actually doing whatever it needs to lower the delta vortex and lower, in other words, give the best helix spin. Because you think about it, the vein is solid and the arrow is turning. What's hitting? The entire vein is hitting the surface, isn't it? So it's not pushing down on the air. But if the vein is turning into helix, the vein is screwing into the air. There's no friction on it. With the texturing in it, that's the reason the arrow will go through air with no sound and no crosswind effect. Now, as a matter of fact, on Aerovane 2, the crosswind signature on, say, a typical 246 arrow, the crosswind signature is 1 3/4 inch. That's big. And the Aerovane 3 is only 1 inch. Imagine you got a 1 inch projectile going through air at 30 miles per hour. Now that's the reason a lot of people don't believe me back even in 2009. They say, go ahead and shoot 120 yards. The gentleman in North Carolina is very kind to challenge me. So I told him, go ahead and put a 36-inch long ribbon, put it on top of target. That's how you usually test how big the wind is. The weapon was totally flat when he shot it. It's on the video on my website, you can see. So you're looking at least 35 to 40 miles per hour wind. The gentleman shot 3 crossbow arrows with broadhead on it at 106 yards, ruined 2 arrows. I think that should pretty much sum it up. So wind has 0 effect on this. I mean, I would say that when you're pushing 150 or 175 yards, you may see 4-inch deviation, but I think that's really pushing it. Archery at this current stage, I say 130 yards should be the maximum based on the current knowledge. Anything beyond that, I would say is more luck than skill. Now, as we move from Aerovane 1 to Aerovane 2, this is a lot of people didn't understand what the major difference is. And I want to show you a few things very interesting. Aerovane 2 actually is a super efficient airfoil. If you know aerodynamics, it's about 72,000 Ronalds, which means that the lift capability is like slapping a Hercules on the F-16. Just ridiculous amount of lift. But then, as we learn a few things, I mean, I went through a lawsuit with the new archery product when I first came up with it. Because I'm going for the most efficient, except new archery product on the quick spin have a pattern. The left side and the right side are different. So I had to redesign my vane. Well, that actually helped me out. The original Aerovane 2 is very soft. The aerodynamic elasticity is extremely efficient, which means it's spinning extremely well. Well, guess what? It's great for target. It's horrible for broadheads. Because currently most broadhead is handled between 8 to 12 spin revolution every 20 yards. When you start throwing 90 at it, what do you think is going to happen?
I called you and told you what happened. I don't know if Scott knows, I made up a set of gold tip pro hunters for a customer. And I put the Aerovane 3s on. And he came back and snapped all his broadheads.
Snap the ferrules.
Snapped the ferrules.
Really?
So he was running expandables and it just folded over the blades. And so he went to just standard broadheads and it broke the ferrules. So I had to strip all those off.
And put Aerovane 2s on.
I put the Aerovane 2s on.
See, the Aerovane 2 version 2.0 dropped the efficiency of the rotation by close to 60%. So it's only rotating 40 times what the original is. Yeah. So what happened, the original Aerovane 2 is so efficient in turning. The new Aerovane 2, which you currently buy, is only doing about 40% to 50% what it should be. But it changed the story because my Aerovanes are so efficient, it's great for targets. The moment you put broadhead on it, the broadhead are not designed for this.
I was amazed. So I called Dorj up. I'm like, wait, because no, Aerovane 2. I'm like, I just strip all those off.
So you recommend the 2s for
Two for,
broadhead?
no, actually it's not. 2 for people who don't know what they're doing, and 3 for everybody with education. Because Aerovane 3 have a lot of benefits to it. Because it stabilizes the arrow even faster. Most vane will not stabilize the arrow until about 9 feet out. Aerovane 2 and Aerovane 3 will start to spin the arrow about 1.5 feet in front. That means the moment you leave the bow, if anybody told you the arrow starts spinning, they are lying. The arrow never, ever spin until 1.5 feet, usually 3 foot out.
You can see it on the slow motion camera.
Exactly. But they will tell you, no, you spin the moment you leave the string, like some company will tell you. No, they don't. Because if you do, you're never able to shoot the arrow. You have no control of it. What's your arrow doing? Which we're going to talk a lot more about that, especially on the arrow shaft, and also the bending, the curve, and also how the arrow draw curve actually happens. We'll talk about a lot more in section 4. But let's go into the Aerovane a little bit more deep. You notice that right now, as we say, there's that many sizes of arrow shafts. How many different helical vane clamp do we have in the market? Now, do we understand what helical clamp to an arrow shaft mean? You are trying to draw a curve on the arrow. And how many arrow sizes on the OD do we got in the market? And you are telling me you have to find a metal piece will fit every single diameter, every single angle, every single offset, and you'll fit that thing perfectly. I would like to see that in tooling. The answer is that you could not. That's not possible. The only thing you do is throw a lot of glue in it to fill the gaps. In other words, you're using a whole bunch of super glue gel or Golden Platinum Plus as mortar to fill that gap. Now when you do that, what does that mean to the weight and the strictness of the vein on each of them? I can guarantee none of them are right. Now, in the case of Aerovane, what are we really doing? We are putting the vein on the tangent of the shaft. I don't care what size of a circle is. The tangent is the tangent is the tangent. Now, if you look at this picture previously, right here, this is critical. See that right here? This curve right here? This curve is a 3 millimeter radius, a diameter. What does that mean? That means I personally believe that there's no arrow shaft in the market you want to use this vein that's smaller than 3 millimeter in diameter. Olympic class arrow is 4.5 millimeter in OD. Remember, 1664 millimeter arrow, we're talking ID, not OD. Okay? So, if you maintain that, that means what happens when I put that piece of vein on a shaft? The vein feed is going to do this, isn't it? So what your total adhesion surface is absolute, entire vein. If you think about it, a lot of companies, they put the vein feed really narrow. How much glue can you put on it? And how much are you relying on the vein is staying straight up? Because if you put a little bit glue, and what happens if you glue it and the vein is not wide? The vein feed would. Now your whole vein is offset, not just perpendicularly, but sideways. So how are you controlling the vein? You're not. Now, a lot of people, when you look at veins, they don't look at the process of veins, putting it on. When I first come up with Aerovanes, I was hoping that I'm able to use something like Jojan, Bissenberger, and I do some testing. On a totally worn out Bissenberger, you can have no better than a 5 degree as worse as 7 degree per era. Go home and look at Bissenberger, hold the chuck and shake it left and right, up and down, forward. And ask yourself how much play that is. And then you rotate the index. Then ask yourself the question, how does the vein, the knock, and the index connect? The moment you rotate it, when you go past the second 120, the arrow shift. The Bissenberger is designed for the 2219. How many arrow shafts you shoot is the 2219?
Not anymore.
Next question, you notice the arrow dropped a little bit, and if you do that with all those conditions, how is your vein interact with the shaft when gluing? So how do you guarantee the vein is on? You can't. Now remember, the Aerovane is put on a tangent. That means I'm using a resulting angle of the lift. So all three must be, on the in case of Aerovane 2, the accuracy of the jig has to be no more than 1.5 degree. No less than 1.5 degree. More preferably 1. And the Aerovane 3 is approaching 1/4 degree. So how are you going to fletch that with anything else? Well, by chance, I was very lucky to find a gentleman from Zenith Archery. That is where I'm able to show the world before I build Aerovane jig, how to use it. Because a Zenith Archery index putting in a Bissenberger, you are about to get 1 to 1.5 degree accuracy. Because what happens is that you're controlling the inner ID of the shaft with the chuck. Because the original Bissenberger chuck, the indexing chuck, inside the things is too much play. The Zenith Archery makes it significantly tighter. But there is still no control between the chuck and the index. So yes, that's about 1.5 degree play. Then I asked myself this question. How accurate is good enough? See, the first one, when I designed the original Aerovane jig, I finally convinced nobody on this earth would buy it. Because nobody's going to spend $4.5 grand on the jig. Not when you can adjust 1/28 of a degree offset with the titanium magnet clamp. Because I'm trying to give everybody everything, including a helix clamp. But the only way I can possibly do a helix is using nickel titanium magnet on the spring load system. So when the magnet goes on it, it'll force itself onto the thing and find its own way. But nobody going to spend $900 on the clamp. So that's off the question. And nobody need to do offsets. Because see, when you use Aerovane, the downside with Aerovane 2 and Aerovane 3 is that the moment you go under 260 feet per second, you need half a degree, or 1/8 of a degree. I found out that in most cases you can manage it with the current Aerovane jig. And that's the reason we go a little bit a route like that. Then I also discovered the problem with vein adhesion. I was doing some research, to give you some numbers so at least you got some idea. A normal vein with a normal glue, do you know how much the weight of a glue that people put on a vein? A normal blazer, 2.5 degree offset, how much weight of the glue is on the vein?
It's probably 2.5 grains.
0.8 to 1.5 grain. And let's sit back and think about what I just told you. What is the percentage of margin? It's 100%. How many things, that means pretty much I'm telling you, when I balance your tires, some of them are 50% off. How would you drive it? But you accepted it. The industry as a whole accepted that margin of error. And with the Bissenberger jig that's worn out, you're looking at 5 to 17 degrees off. Just sit a second and think about what I just told you. Now, how do you know a set of vein fletching is done right? Very easy, I will teach you that. Lay out half a dozen arrows on the table and walk back. If one of them is about 2 degrees off, you can see it visually. Because every one of the veins should be pointing up straight up. That's the reason you find out the best arrow builder will always show you with all the arrow laying on the table and walk back, taking a picture from the front to the back. Because every single mistake is shown. Every single perfection is also shown. And if you do that to an arrow and look at it, you know it's right, or you know it's wrong. Because it's in any arrow, it will show. Because see, when you put an arrow on a 3-prong arrow on a table like that, you are seeing all 3 veins. Because the 2 veins are touching the table with the 3rd vein straight up. If any one of them is error in it, it shows immediately. And that's the easiest way to show you. Now, of course, I went through more than what most people would with the veins adhesion. Let me give you a hint. I went through a lot of issues with, because at first I always figured there is enough stuff in the market, there's no need to invent it or create it. When I first come up with Aerovane, I used Bowling Platinum Plus, using primer, whatever. It didn't work. So I got mad. I spent a day and a half talking to the engineer in handcuffs. And then finally go through all 30,000 Sana acrylite and come up with the right one. I'm happy to tell you, with my glue now, this one, this glue. A lot of you have already used my glue. I'll tell you, if you are trained and certified, this bottle of glue, which is 1 ounce, will fletch you 80 plus dozens of arrows. How come? Because see, I was doing a testing and find out how much glue I needed on my veins. To fletch 3 veins Aerovane using my jig and my glue, you put 0.03 grain of glue plus and minus 0.005 grain of glue per vein. So the maximum glue per arrow is 0.1 grain at max. Now remember how much glue you use in the other brand? 0.8 to 1.5 grain per vein.
I saw arrows this week and I had 5 grains per vein. I was like, holy moly.
And right now I'm telling you, I'm giving you 0.1 grain of glue per 3 veins. Put them on numbers. That's 10,000% difference. On a 3 to 1 ratio, I'm actually closer to 30,000% difference in weight. Now, if you look at my video with Jim Burnsworth, the beauty of this system is that if you run an archery shot with my jig, you can fletch a full dozen arrows in less than 10 minutes and ready to shoot. The beauty of this is that this vein glue takes 9 seconds to set. After 12 seconds, it takes 680 pounds to pull the vein off.
Carbon comes with it. The carbon comes with it.
Correct. You can break the vein material, you can pull the carbon with it.
You can't except around victory arrows.
And now a lot of people don't understand it, and let me go through that process with you. Because I think using Aerovent is very critical on the installation process. The current carbon material of all aero shaft, don't use denatured alcohol. Don't use anything else. 100% pure acetone. People will tell you, oh my God, but you will melt the arrow. No, it won't. The only 2 grams of arrow it can possibly do something to it is carbon force and the obeamine, because they are resin-based rolling. All arrow today are epoxy-based. Acetone have 0 effect on it. But see, originally I designed the Aerovane glue based on toluene and a few other exotic materials. Since I'm a nuclear chemist by education and pretty decent organic, I found out one thing: you guys will end up with a lot of very toxic substance. So I shift the entire formula into acetone. First of all, it's readily available. Second, it's naturally occurred. In other words, if you pour it down the drain, nobody get real hurt. So you make it easy to work with. Now, does acetone have some bad thing about it? Using veins, answers to that, yes. The Aerovane, the whole process of Aerovane gluing process is based on the lifting of the release agent of the plastic before you glue. A lot of people do not understand it. Every single vein in the market, there's only 2 processes to make it. One is called extrusion, the other is called mold making. The extrusion process, that means you got to die, you force the plastic through it, and then it's come out, you die cut it. Okay? What's the bad part about this? This is cheap, this is great. What's the problem with this process? If you are really a person that understands it, and if I give you 1,000 pieces, 1 pack color blazer, what's the weight variance? 2 grains, plus and minus. That means if a 5-grain blazer, the heavy is 7, the lightest is 3. Let's sit back and think about it in percentage. What's the weight percentage variance? It's 133%, isn't it? Is that acceptable?
No.
So a lot of people sit there and they weight all the veins and put it back together. Now the question again. When you do extrusion, how do you guarantee the thickness? Even the same way, from front to back.
Can't.
Exactly. Now you know why some veins flutter worse than others. And then, unlike other companies, I only use German Macaron dye. That means no matter what color of my vein is. On the Aerovane 3, I'm giving you a 0.07 variance on any veins, any color, any pattern. On Aerovane 2, I'm giving you a 0.1 to 0.98 grain variance. Any color, any form, any shape. I mean, in other words, if you go look, notice the moment when you buy a pack of American flag vein compared to a camel vein, they are not the same weight, they are not the same flags, they don't behave the same. So how do you expect an arrow fletch with 3 different ones or 2 different ones to spin the same? You couldn't. But everybody seems to be doing it, isn't it? I want 1 5 vein and 2 American flag vein. It looks cool. Absolutely, no doubt about it. But how's the flight? Oh, I'm only shoot 20 yards. I understand. That's good enough. You're not my customer. But that is what the state of the market is. But then when you look at what I'm giving you, now you know why Aerovane. Aerovane is a single cavity, single mold vein again. That means every color of every Aerovane go through the same mold, same cavity. It's an extremely expensive process because, imagine, when you go extrusion, you're talking something like 40 feet per second, flying through. I cut chunk. 4 seconds later, I got 1 vein. And every one of them go through my 15 cavity impression mold. So I can pretty much guarantee you every one of my veins is the same. So it's not a mass market vein because it will never be that cheap. But then you get what you pay for. And that's the market I'm after. And that's the market, in some way, I believe that your customer wanted that. Because they don't really care about cost, they want to win. I mean, just like the old saying, the number 2 is the first person who knows he lost.
Yep.
And the people who want to win. Like the old saying, what part of the detail you can forego to win? Answer is none, or you just got lucky. I know there's people lucky all their life, but it's just not me and my customers, or the people I teach. Now let's go into it a little bit more detail about Aerovane position, and also what's going on. Now a lot of people ask me, Dodge, what is the best position of the Aerovane on an arrow, theoretically? I mean, think of Aerovane as a rudder. The best position of the Aerovane is actually halfway hanging out behind the arrow, behind the neck. That can't happen. So what is the best answer you can give? The best answer is that it's as close to the back as possible. The stiffer the shaft, the more forward you can put it. The softer the shaft, the more backward you're going to put it. What with the Aerovane, which will lead me to a lot more, is that the Aerovane also happen to give you a lot more how the vane and arrow interact. Think about it, when the vane is turning a shaft like this, and the shaft is now is flexing. Remember, the shaft flex in 2 points. One is a null point in the front, and this just before the vane. Those are the 2-point flexing. And sometimes right near the vane. And some of the really bad FOC, like heavy FOC, the flex point is right in front of the vane. What is that doing to the vane and the air that's interacting?
It's taking it to the belly radius.
It's now flapping every single direction except where you want it. So the earlier the arrow is going into a gyro, the better off you are. But this is where the problem that everybody did not know until I come around with a few nice gentlemen and find out. Do you know, besides aluminum arrow, every single carbon arrow flex in a tight elliptical form? In other words, they flex like this. While an aluminum arrow will flex like this, exactly in axis, as an axis change. And when you do that, you're giving Aerovane a lot more benefits. That means it's going to elliptical gyro, no, now to a true gyro earlier. It's not fighting the elliptical gyro. That means the interaction between the air, the shaft, and is now getting straighter. That means also your drag become lower. Now, if you minimize the drag with Aerovane, what's happening to the shaft? Think about it. As the arrow travels through air, the arrow is flexing, right? What does flexing mean? Elasticity energy is being used. What does it mean to the surface friction? The moment you hear fluttering, sound is created. Yes, sound is one of the lowest and cheapest to create in energy form, but it's still energy. So if energy is being robbed away by sound, you can guarantee there is friction, right? Surface friction go drag. So what happened to an arrow when you add all those to it? It's not moving forward. As the arrow energy is being lost, its hand maintained energy is dropping faster and faster and faster. Now this is the part that for all of you who have used Aerovane will find out. This is what an arrow, when you shoot an arrow, this is what an arrow fly like, and then eventually target like this. Am I right? 60, 80 yards. Now, the moment you shoot Aerovane, the arrow goes out like this, and then you would descend and hit the target like this. What's the benefit? What's the big deal about this? Why is hitting a target perpendicularly so perfect, so important?
Less drag, more forgiving.
Not just that, yes, all of the above. The most important part is that the arrow now, the hang time is significantly longer. So that's the reason if you just use a basic Aerovane 3 at 60 yards, same arrow, same identical launch speed, you see 4 to 5 feet per second, not 4 to 5 inches higher. The average person would just change from Aerovane, from normal blazer to Aerovane 2. On a medium twin bow, you're looking at 6-inch difference. With the Aerovane 3, it's 9 to 12-inch difference. On impact.
Yards?
Yes.
60 yards.
No, it's not a joke.
Fun stuff, huh?
I mean, Eric Black out of Black, who have been a pro staff for bowling for years. He called me 4 years ago and said, I heard about your vein. Next thing you know, he spent $1,700 with me. And he only got 30% off as a pro staff of my products. And he's still using it. We are talking about, just like we have discussed about 2 years ago in Harrisburg. I just want to win. That's his answer. You can get free stuff, but you want to win. And this seems to help him, and he's still using it. And remember, this reason I always tell my customer, you don't expect to get free stuff from me, but I'll give you the best. You decide whether it will help you to win. If you get stuff that don't win and for free, it's your choice.
So, question with that, which is something that we talk about on a regular basis, and we can answer it offline if we need to, but is that hang time calculation something that is able to be measurable?
Nope.
Reason being, okay.
It
That
is not.
answers the question.
That was one of the most difficult part.
Yeah.
Because see, we are talking a complete projectile.
Right.
I will tell you a few things with Aerovanes, indoor, without Aero Concept system, 8% FOC is what you're looking at. The moment you go Aero Concept, 6% FOC. Hunting, 8% FOC with broadheads, which most people will just think is crazy. But the problem is that, like, I have a long discussion with a very educated German dealer. He told me I'm the first person addresses the Aero and Vane itself. 99% of people was looking at, imagine this is Aero. They're looking at this white cap only. That's the broadhead. Or this is the field point. I mean, it is the same concept. Imagine you're going to hammer a steel pole into the ground. What if the steel pole is flexing and you're trying to hammer it? How far is it going in? In most cases, it could work itself back out. But if the steel post is in perfect spinning, or the steel is not moving, the more you hammer it, it goes straight down. Because see, the moment you're able to calm the arrow, you're no longer looking at the broadhead only, and the rest of the arrow as nothing. The same thing again, I mean, when you look at a 400 grain arrow with a broadhead, 90% of people thinking that 125 grain in the front, which is broadhead plus the insert, is the only thing that kills the arrow. The rest is a delivery. But what happens if you're able to use the whole 400 grain and hit the target? Because if you do that, every single grain on the arrow shaft all the way to the knock are pushing forward, like a freight train pushing the entire thing forward. Now think about it. If this thing is hitting a target at an angle, what is it doing? This is doing this, isn't it? But if I go in here like this, what's the force going?
Forward.
We found out, even just with Aerovane 2 or Aerovane 3, you add about 9% more KE based on speed. Because there's no sideways deviation of force. That's the reason Aerovane, I mean, first of all, the Aerovane go to the animal quietly. I got a few customers like text us. I remember one of the customers told me, he shot at a freaking deer 6 times, he finally killed it. He bumped his sight when he go up. He finally killed the deer by shooting right into the neck and dropped it. But the deer never hurt being shot. How big deal that is? I always tell people, imagine this, like in 2008, 1968. Yeah, 2008. I go and shot, when I first come to Aerovane, I shot at a 4-point buck 4 times, under the neck, behind the head, and so on. He never looked back. How valuable is it that just in case, in the extreme case, you missed it because buck fever kicked in, I give you a second shot? How much are you willing to pay for it? That's a question a lot of people never ask because they never know it can be done. But all of a sudden you're giving that. Would you want that? How much are you willing to pay for that? And not to mention, see, even with basic Aerovane, of course, right now I push this formula a lot more, which we'll talk about in section 4. How I'm able to make, this is the fun part, how I'm able to get a 60-pound bow with a 300 grain arrow, deliver more energy than an 80-pound bow with a 400 grain arrow at 60 yards. That's a big deal, isn't it? Because see, the moment when you start going to it, and any customer over the 50-year-old, They are the one who finally get some money and time to do their hunt, but their body may not be the best. And all of a sudden, they want the elk hunt and so on. They can't do the 80-pound bow, 60 yards. And all of a sudden, you can tell them, I'm going to give you extra 22% power at 60 yards using a 60-pound bow to match the 80-pound bow with a 400-grain arrow. How much are you willing to pay for it? Answer is that they will pay you anything. Because that's the ones that are last lifetime hunt. And so far, every one of them that I did, I achieved it. This is not a small deal. That's the reason I have to have this course to teach my dealers how to build arrows and bows so that they can give a customer extra 21 to 28% more power at 60 yards instead of losing that 30 to 35% power. And then with Aerovane 3, in the crossbow situation, this is where they get interesting. I was being told wrong so many times, but every time when I was being told wrong, instead of getting angry, I want to find out the truth. One of my customers told me, Dodge, you know, your entire concept of Aerovane, aero boats, and so on is great, but I did something exactly opposite you said, and it worked better. Then I learned one thing. He was using my Aerovane 3 with extreme FOC. We're talking 35%. What I discovered, so the normal arrow projectile, when you go for about 60 yards, you lose 30 to 35% energy. At 100 yards, you're losing 40 to 45. And with extreme FOC on a 720 grain projectile, I'm able to lose less than 2%. Do you understand what that means? That means that a gentleman out of North Carolina was called Twine and Bang. He was kind enough to show me with my system, with the Jim's crossbow, with my Aerovane 3, with any of the dagger system, it'll go through a class 3 safety vest at 100 yards. That means you can wear a bulletproof vest, the arrow will go through you with no sound. Which means, we're not talking about killing people, but what does that mean? That means that with Aerovane 3, you can do an inner city hunt, like in Virginia, Vermont, Oregon, all those places are inner city hunt. You can now shoot an animal at the shoulder blade and go through it and drop it. Because just like some of the places, you're allowed to hunt in everybody's backyard. Let's sit back and 1 minute and ask yourself this question. How wide is a normal city block's backyard?
Probably 50 yards, 60 yards.
No, 40 feet.
40 feet. I was
40
gonna say
feet.
40 by
40 feet.
Yep.
Now the animal walked into the yard fully 3 foot lost. You shot it. It will drop in 20 yards. Where is it?
It's on 8th
Under the
Street.
neighbor's back porch.
Now I did that in volleyball. I shot a deer not good. It ended up bleeding all over the rich neighbor's tennis court and come by. Next thing you know, deer now everybody showed up. You just shot a deer. I did. It was a bad shot. I know. What can I say? I mean, if we all make perfect shots, there's no point for competition. So
the reason I asked the question on the mathematics is because one of the challenges that we have from a tournament perspective is sight tapes.
yes,
So sight tapes it's just mathematical calculation based on gravity, arrow speed, blah, 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 and it gives you your range for your sight tape.
that's
So
exactly
with
the difference.
Right, so with an arrow creating lift, we get inconsistencies in being able to measure that because it's not dropping like a normal-
Exactly, and not to mention the not dropping based on arrow speed is totally different.
Correct.
Like if you shoot a fat arrow, like a high spine arrow, that's just like a 60 pound, 400 spine, 31-inch arrow.
Mm-hmm.
The dropping you won't see the major difference until you're about 45, 50 yards. If you shoot some like a Challenger, 350 spine on a 65-pound arrow, the difference are showing at 30 yards. And the
That's where
difference
we're
is
seeing the problem.
dramatic.
Right, and that's where we're seeing the problem is trying to figure out how to calculate for the marks.
No, you can't, because it's a combination.
Right.
Because it's not just the vein.
Right.
Because as we move forward into the section 4 of this class, you learn that in some cases, your 70-yard pin equals to 106-yard pin. You just gain 36 yards.
So how how do you come up with a site take?
You don't.
You don't.
You shoot every 10 increment.
So you shoot every 10 increment and you use an index card based on your calibration?
No, you simulate that, then you mark it. When you finish marking it, take it over, and then you put it in the program, then you print your site tape.
Yeah.
You'll find it's really weird. The site tape is like 10, 20, 30, 40, 50, 60, 70, like that. It's not a true locker form. It's based on your condition. All of a sudden, when you go up to about 80 to 110, that all of a sudden it gap and then you start dropping again.
I've done the hand ones and it's 20, 30, it's like, wow, those are the same distance apart.
Yeah.
And then all of a sudden it starts opening back up again.
But then the benefit is that if you do this, especially in the crossbow situation, if you do everything just like in the case of Raven, a lot of my customers find out just by using my vanes and also my knocks, that 20-yard pin just become the 30-yard pin immediately. And that means that you can now point an arrow at any animal under 40 yards, don't even care, fire, you're on it. Right. On the vertical bow, anything under 40 yards, if you shoot over, say, just under 310, which is normal, you can point on the top of the deer, anything under 40 yards, you can shoot it, it will be killed. Because you've got a margin of this far. That's your 40-yard margin.
So as we do that, so when we talk about the aiming and holding off and adding your yardage and what it is, how we do our system.
That's what I'm thinking, the longer yardages is where you're gonna gain the most benefit,
Correct.
and get the most forgiveness.
Right.
Now, the thing is that this is another big deal, is that when you all of a sudden, when you start shooting raiding, or some of the people like in Spain, the undervalley swirl, imagine this, I mean, like a few of my customer from New Zealand call me, he say, I'm at 82 yards looking at elk, the wind is blowing at my face, I'm going down on it and shoot. In 90% of the time, I know I need to aim way low, and then at the same time, I have to aim high because of the wind. Now I can just point exactly where it is, as long as my form is right, the arrow is pointing where you need it. If you look at my 2016 catalog, that New Zealand elk was shot at 82 yards, downhill, 45 degrees.
45 degrees.
Wow. The arrow go down like this and slowly descend and hit it like this.
Like a paper airplane.
Yep.
See, this is where a lot of technology and the dealer education come into it. Because now you start teaching customers, I can do this for you. And as we go into section 3, which we're going to start, I'm going to start teaching you how to shift the FOC of arrow away and how you change and make the entire arrow count. Because all of a sudden, like, I don't know where you recognize, for the last 3 years, all the Canadian 3D is one with arrow with Firenock components. As a matter of fact, on the last 3D indoor, the top 5 are all Firenock, and then it's 4 points away, the rest of the guys.
Yeah, they do. So we weren't talking, but I made 27s up at 600 grain points. Put the Aerovane 3s on, and the target flies as pancake. I didn't get none like, bad shot, drop right out into the 8. They never dropped. They just sat there flat. Chuck was just going. That's when I called you, because I was having a hard time getting them to stick to the X7.
Yeah.
The aluminum
Right.
X7.
The problem is
we've
that
had issues with
aluminiums,
right, that and victory arrows because of the coating. that
ice
they put
coating,
on
you
the
need to scrape that
outside.
off. See, X coating, you have the physical scrape because it's an epoxy coating. You have to scrape it off. Now the problem with aluminum, this is where the issue is. Most people don't understand. When you use the typical old glue, what you're doing, you're putting mortar on top of a surface as big as possible to increase the footprint, so that the vein sticks. What is aluminum arrow? It's a 7000 series of aluminum that's anodized and sealed. What does that mean? That means your total contact texture on the surface is less than 0.5 millionth of a square inch. So what are you grabbing?
A whole lot.
Nothing, you're grabbing nothing. But then at the same time you look at carbon arrow. What is carbon arrow? How is carbon arrow surface being treated? Carbon arrow is using a centerless grind underwater with a grinding stone to get the surface. That means you are guaranteed at least 30 thousandths of an inch in surface texture. Now remember when we talk about the glue using acetone? Now every single vein in the market have release agent in it. What is a release agent? Release agent is a long molecule mineral oil that's embedded in the vein. The moment you put acetone on the base of the vein, you lift that mineral oil right off the surface and you clean it. Now you got holes on it, right? Because when you take the molecule away, there's holes on it. You put the cyanide on it, it becomes rooted in it. The more you turn around and you force it on. Now I will talk about more on how the vein and jig interact. The moment you do that with my Aerovane jig, just by putting your hand on it, you're putting 60-pound pressure per side. You're putting total 60-pound pressure of the vein coming down. You only got 6 to 8 molecules thick of glue on it. And anybody who knows glue, the glue is not structural. The glue is bonding between two surfaces. The thinner the glue, the stronger the bond. The moment you put glue like boning platinum, all the rest of the glue, they got thick. What is the structure of that glue? It's the glue itself. Cyanide acrylate is not a good, strong agent. Ask yourself, how many acrylic you know is strong besides ballistic? But that only strong when you have to add the thickness to certain. When they're this thin, they're worse than your glad wraps. So now you think about how the process interact. The moment you're able to control your glue, you get your bonding surface, you got your exact location, your circular lift become accurate. Because remember, there are 3 things spinning. If this string is off-center, one of them is heavier, it will do this. And if this is not straight, it can't turn, it will be turning off like that. So the accuracy of the vein itself and the glue surface is critical. Now, then go back to what happened with aluminum arrows. Can I do that? Answer is yes, you can do aluminum. The first thing you have to do is you destroy the surface. In other words, you etch it. NSA is a good approach. And some people use comic. You know, scraping comic on aluminum. What you do is that you want to create a bonding surface. And yes, in aluminum cases, and a lot of people say, what happens if I put a wrap? Since we're talking vein, let's go in and talk about wraps. What is a wrap? A wrap is a piece of plastic or vinyl with a thin spray of glue underneath it. The absolute best is from 3M. And I did talk to 3M. They can't guarantee me 20% thickness guarantee. That means the moment you put on it, assuming you do not have any of the overlap, your total surface is you just added 20% variance in the circumference of the shaft.
So one being sitting up higher, lower,
or angled. Now, there's another thing is people say, well, what happens if I want to reflux? This is another thing that a lot of people do since we're talking about veins, is that, I will scrape the vein off. Anytime you mechanically touch a carbon shaft, you're taking powders away. So what you want to do is you want to use something like a zip strip, you want to take the vein off, and if you take all 3 off, you should throw the arrow into acetone and chemically dissolve the glue. I designed all my cyanide acrylic glue, Aero AGO 600, AGO gel, are all 100% acetone dissolvable. That means the moment you put the vein in the acetone, about maximum 20 minutes, the vein will fall off with 0 residue. That's the reason you should see all my pumps with 3 bottles. One is called a dip, rinse, and flush. The dip is to clean the shaft, the rinse is take away the residue, and the flush is to when you clean the base of the feet. Is there any downside to this approach? Answer is yes. The moment when you start flushing Aerovane in 18-degree humidity, in cold temperatures, the vein gets brittle. The moment you do that, that's the reason a lot of my customers say, hey, Dodge, I'm halfway through, say, the first one in Virginia. My Aerovanes are breaking off. I say, I bet you're flushing in a really dry area. Because at that moment, think about it. You put acetone on the base of the vein. It's not just taking the molecule out, you're also ripping the only moisture in it. Just like your skin. If I take every moisture in it, what do you think it's going to do to it? It's going to crack it. As temperature drops, there's not enough oil. The veins are cracking right in the front. In other words, the vein is going to crack right here. See this area, this air channel? Oh, by the way, do you know why there's an air channel there? That's actually it's a trick question. Why do I need an air channel for this vein?
We have to break up the surface of the air first to divert milk.
Nothing to do with it. Actually, this is a pattern process. Look at this picture, right down here on BB. See the BB right here? You notice the left and right side is 100% identical just in the channel? If I make a vein all the way down to the base, if I have different diameter arrow, what's going to happen to the vein? Isn't it? A lot of people, they thought they know better, and some of the customers are feeling that gap with glue. The moment the temperature changes, the veins are doing this and this. You just got some wonderful customers sometimes. They seems they know so much, and they are teaching me a few things. I say, you know what? I went through a 55-hour wind tunnel testing with this stuff. I think I know a thing or two. Not saying they don't teach me. Believe me, some of them do. Sure. But some of them just so far out to the point we're not even in the same room anymore. But you can see this is the reason that we can fudge Aerovane so perfectly straight. It's because of this, right? See that right here? Does it help? Now you understand why you can fudge your Aerovane in all the different size shafts. The vein always come out perpendicularly. Well, that concluded our section 2.
Cool.